Jam, where packets will move slowly. So congestion can be defined like this: too many packets present in the network causes packet delay, or sometimes loss of the packets. That normally what happens once the queue fills up, the the intermediate nodes will drop the packets. That certainly, when dropping of packets happens, so that will degrade the performance of the entire network. So this situation, we call it as congestion. And congestion happens due to more of packets moving in the same direction, and of course it's just like traffic jam. So if you ask for the reason why traffic jam, because more packets or more vehicles passes through the same junction. So what happens, there will be a lot of traffic jam. The network and transport layer share the responsibility of handling, controlling this congestion. And of course, the most effective way to control congestion is to reduce the load. So reduce the load, reduce number of vehicles on the road. So what happens, automatically the traffic will flow freely. The same way, reduce the number of packets, automatically it will rectify, the congestion will be rectified. The most effective way to control congestion is to reduce the load that transport layer is placing on the network. Yes. So how to reduce the load? One very important thing is create more parallel routes. Okay. So if there is only one route, definitely there will be a congestion. Instead, you have underpass, you have flyover, you have other parallel roads. So automatically congestion, traffic will be, parallelly moving in all the paths. So you can certainly avoid that kind of congestions. So we have seen earlier, Hebbal used to have a lot of traffic jam. So due to flyovers, it could able to sustain. Same way, create parallel routes. Mandalay Junction, lot of packed traffic was there. Now free flow due to this flyovers and underpasses. So just the same technique that is followed in networks also. A stream of packets begin arriving on 3 or 4 input lines, and all they need to go in the same one output line. So where a queue is built, and once the queue is filled, automatically packets drop. This is the reason for congestion. I think we have done this sufficient number of experiments in computer networks based on this. We have worked, right? And if there are insufficient memory to hold all of these incoming packets will be lost. Yes, that is dropping of packets we have seen. Adding more memory may help up to the point, and of course, but what happens, sometimes the outgoing line is having low bandwidth and incoming line is having more bandwidth. So definitely router will face a lot of problem with respect to congestion. In this case, the situation can be improved by directing some of the traffics in other parallel routes. So that is the only reason. And for this, the routers need to be very, intelligent enough to find, detect congestion. And if the congestion is happening, automatically it has to redirect to some other, direction. So that is the thing. So there are approaches to control this congestion. One is increase the resources and decrease the load. Increase the resources. Increase the resources in the sense bandwidth you increase, parallel cables you lay. It becomes very easy. So since more people, more cables means automatically the traffic will flow. And most basic way to avoid congestion is to build a network that will match the traffic that it carries. Yes, you have to build a network in such a way that based on the traffic, you have to accommodate the number of lines, number of paths, etc. These solutions are usually applied on different time scales to either prevent congestion or to react once the congestion happens in the network. The most basic way to avoid congestion is to build a network that is well suited, uh, that can manage the entire traffic. So there are two difficulties that we expect out of this approach. One is to identify onset of congestion. How to identify onset of congestion. Second one is how to inform the sources that needs to slow down. So if at the same speed, if the sender is sending packets, what happens? It will fill up and it will create a traffic jam, congestion, gone, packets will be lost. The solution is the routers can monitor the average load. So average load on the queue, and automatically once the queue is about to fill up, and automatically it has to understand, so quickly the queue is filling up. So what I have to do is I have to send a message back, that is feedback loop, to the source, so that source systems source computers should slow down, should send. So their delay is increased. Delay is increased since instead of transmitting 5 packets per second, it can transmit only 1 packet per second. So the rate of transmission of packets will be reduced. So automatically, but will the customers really happy if the network becomes slow? Absolutely not. People want as quick as possible. They need not have to wait. They have to get downloaded as early as possible. They have to install as early as possible. So their transaction network, everything should go, quickly. So nobody is willing for a slowdown. So this is the biggest question. This is the biggest problem for congestion. So there are solutions, some solutions available. One is traffic aware routing. This is one of the solutions. If there are 2 paths, just imagine. See, look at here. There are 2, networks. One is east network, another one is west network. So if the line CF is very shortest and the EI is longest, so no problem. Most of the people use CF only. So even though it is shortest, transmission happens every time there is a jam at the C, there is a jam congestion at F. So in order to avoid this, automatically what happens, C and F will divert some of the traffic through E and I. So E and I is also parallel route to reach, to connect East network with West network. So this is one of the problem. So based on the traffic, the router can route the packets. Router can route the packet so that there is no congestion. So you have to write some built-in algorithms inside the router. If there are more packets, if there are more congestion, so automatically it has to be taken care. So that is traffic aware routing. So that is one solution. Second solution is traffic throttling. Traffic throttling is intentionally slow down of the service. But this is a very, uh, very against the law of, business. So intentionally, the internet service provider will automatically slow down. He knows there are traffic going to happen during evening time. So he knows the capacity of his entire network, 30 Mbps. 30 million people can transmit. So what he will do, he'll reduce internet speed of each and every person to automatically 1 Mbps. He reduces. Since there is a limitation of 1 Mbps, automatically, even though you have a network, your network can go maximum 1 Mbps. It cannot transmit beyond 1 Mbps. Your mobile phone or your laptop. So intentionally slow down. So when intentionally slow down happens, more people are there during evening times. All are using. So there will not be any traffic jam because the speed itself it is. And sometimes it is automated. Based on the number of users, automatically your speed will reduce. So router will automatically reduce the speed. So just to avoid transmission, transmissional congestion. So this is traffic throttling. Traffic throttling is another solution, and it is being followed in our mobile networks even today. So if more people are using, automatically the routers will reduce speed automatically. The same speed you will never get. Okay. So if the number of users are less, automatically the routers will scale. So you will get a very good bandwidth, your very good speed, so that you can enjoy transmission of high-speed network. So next one is choke packets. Choke packet is nothing but it's a packet that is being specially designed to intimate all the source routers to slow down, or to tell the intermediate routers, oh, there is about to happen the congestion in this particular point. Kindly avoid sending packets in this route. So that is what you call it as choke packet. By sending choke packet, a specialized packet that is used for flow control along the network. The router detects the congestion by measuring the percentage of the queue buffers in use, line utilization, and average queue length. Based on this, automatically the routers will send a choke packet across all the networks. It is a flooding. It will flood choke packets across all, telling all the intermediate nodes to reduce the amount of data that they are sending, or they can send in other lines, other parallel lines. So this is another way. Choke packets automatically happens. That is within internet. So it will never come to the user at all. So they will, the routers, intermediate routers will find their own alternate paths, and somehow they manage. This is very complex procedure. The second method. And third method is also called ECN, explicit congestion notification. So explicit congestion notification is a technique where anyhow when you are using TCP, whenever you are using TCP packets have to be acknowledged. Along with the acknowledgement, what happens? A ECN special information, special character is also sent. So this is indicating, oh, there is a congestion is about to happen in this particular path. So all the computers, all the networks, all the routers that are involved in this particular path will certainly understand, oh, there is a about to congestion happens, and they will avoid this particular route. Instead of generating additional packets, so choke packet is actually additional packet. So instead of generating additional packet in the header of the IP packet itself, you have an option called ECN, explicit congestion notification. This explicit congestion notification can be sent. So as acknowledgement, as a reply to the packet acknowledgement. So wherein you can certainly inform the all the networking components in that particular path will come to know, and they will send in different directions or different routes, or they will slow down. The next option is load shedding. Load shedding is nothing but so automatically moving the traffic. Yes, it is also load shedding. Normally electricity, if there are more load in one parts during summer, it happens, load shedding. So they don't have enough power to give. So what happens, every 2 hours they'll cut the power in one of the area, and next every 2 hours it will cut in another area. So it will just like somehow they'll maintain. So load shedding is a fancy way of saying when a router is being inundated by packets that cannot handle, just throw them away. And in terms of the terms come from the world of electric power generation, action to reduce the load on something, especially the interruption of an electricity supply. So it is just like that, just to tell them, just to tell load shedding. Automatically, if the load crosses beyond this, automatically you drop the packets. Without, this is unfair. So sometimes your call will not connect at all. You will be wondering why my call is not connecting, because already there are enough load on the enough calls are that are happening in the network, and if you are trying to do without your knowledge, your call will be automatically disconnected. You will never get a notification or anything automatically without any this one. You will never able to connect. The internet will never work because of this load shedding. Load shedding is one way, so it's an abrupt way to once the load is full, automatically it is not allowing. It is just like you have a bus. If you are having beyond the capacity of the bus, so the driver starts the vehicle and conductor pushes some passengers out and close the door. So this is, I can say, load shedding, just to avoid the load, shed the load. So this is abrupt way, but it is also one of the way that is being used. Random early detect. So with the artificial intelligence today, we are looking into artificial intelligence, and the machine learning concepts, what happens? Our random early detection. So the detection will be easily detected. The congestion will be easily detected. Congestion will be easily detected, automatically. So that is automatically it is detected. Congestion is automatically detected. So it will automatically, sense with the help of, artificial intelligence and machine learning. Automatically it will detect and maintain the entire thing. So it is also called red. The routers drop early before it gets up. The situation becomes too worst. Automatically, it will drop some packets and keep ready to handle. A popular algorithm for doing this is called random early detection, RED, to detect when to start discarding the routers, maintaining, running average of their queues, of course, lens, of course, based on the queues that are filling, the fastness, how the queues are, filling. So it is going to be, detected. And once it is detected, so it is about to fill the last. So it will maintain a threshold. That means if you have a queue size of 100, if automatically 90% is full, so it automatically sends a message, alerts a message, or drop some packets, drop some packets automatically. So this is what you call it as random early detection. So it's also another procedure to overcome the what you call the congestion. Lastly, we have another concept called quality of service. Beyond all these things, you have already promised as a network engineer, as a network service provider, you have already promised that you are going to give best quality of service. So that is you have already promised. So how to achieve the quality of service? So one way is traffic shaping. Yes, good. Traffic shaping in the sense some set of traffic should go like this, some set of traffic should go this way, some traffic in another road, another link, and you have very beautiful plan of maintaining the traffic. So of course, traffic shaping, certainly you can do it, okay, with the help of the round robin algorithm or circular algorithm. So what happens round robin? So one link, one packet, another link, another packet, another link, another packet, another link, another packet. So all the 4 or 5 links will be simultaneously used, and nowhere you will find burden, and nowhere the traffic will get into congestion. So that is based on the queuing procedure, it happens. Next, packet scheduling, transmission of packets. Suppose you are taking backup, and backup is anytime you can take. Okay, so backup will be taken, or your download procedure will be done whenever network is free. Automatically it downloads and keep it. Your backups, it will be backed up whenever network is free. So your system will be waiting. So whenever network is having a less, number of users, automatically during that time backup will happen. During that time, the downloading of data happens. So packet will be scheduled uh, during that time. Normally, what happens after 12:30 night, maybe till the morning 6:30, 7 o'clock, you will get a very good speed. That means because number of users are less, so you can schedule your download, your schedule your upload. Yes. So all the maintenance work will be scheduled during that. So packet scheduling is one way where you can get the quality of service. Admission control. Third one is admission control. Don't allow the packets to enter into the network itself. Admission, to take admission. Why? Because if more packets admit into the network, what happens? There will be a congestion. So you don't admit, you stop the at the entry level itself. So automatically user may not feel bad. If the transmission started and if you are not getting the good clarity, so then you will have a quality of service problem. But if already some people are using, so don't admit more people. So let the users finish using. Later you can allocate the same link, same capacity to others. So admission control is one way. The next way is integrated service. Integrated service follows resource reservation protocol. Very, very important. Normally you have data plans for your mobile, correct? No. So basic plan, gold plan, a platinum plan, diamond plan. So if you use a silver plan, you will get only less speed, less capacity. And if you are using diamond plan or platinum plan, so you have to pay more, and some resources are reserved for you. So by reserving these resources, you will always assured of a good network performance. If you are taken just the silver plan or gold plan, so it is, you sometimes you get good service, sometimes you may not get good service. It depends upon the number of users. So integrated service talks about the resource reservation protocol. So it reserves the resources for prioritized users, and it will give services. That is what integrated service is all about. Differential services means it will differentiate. If it will differentiate and it will give the services. It will differentiate and give the services. So very simple. Very simple. First one is expedited forwarding. Expedited forwarding is moving your packet along with the normal. Moving your packet with some extra care. So it is just like that. If you want to, send some letter to some people, post. So there are two types of post. Normal post. Normal post will go little slow, but it will reach. Same way, you have another post. We call it as registered post. Okay, registered post. It will guarantee that it is will get an acknowledgement. Another post is their speed post. Speed post, special priority is given for speed post, and it will be. So if you want your data to be given or your packet to be given special priority, it is expedited forwarding. Assured forwarding is just like you have a registered post. So assurance, your article or your letter will be reached to the destination with that post care, and you will get an acknowledgement. For normal post, no acknowledgement, nothing. So nothing. So this is what you call it as differentiated services. So these are all some of the factors that are involved in quality of service. So in the examination, most of the times people ask about what is congestion, why congestion, how to avoid congestion. And you have one more lab program on traffic shaping. We call it as a leaky bucket and token bucket. We'll discuss that leaky bucket and token bucket. okay, in Saturday's lab class, and I'll explain that lab program. So, traffic shaping. You are going to shape the traffic based on leaky bucket algorithm. Leaky bucket algorithm is one of the very important algorithm. So, they'll ask that in the theory also and in the lab also. They'll be asking. So, that's all from this particular module. In the next class, we'll start with module 5. So module 5 will start in the next class. So to quickly, I have only 6 minutes to go. So quickly I'll revise module 2. What we will get in module 2 that we have to, because Thursday morning 9:30 you have internals, and for those internals you should be get prepared. So this time 10 questions are from module 1 and 20 questions are from module 2. So module 2 notes I have already shared. So what certainly you get in module 2 is normally error detection, formats of framing, frame formatting, and others. So getting connected. So what are the different 5 issues? So certainly one is a framing problem, error detection, reliability, that is transmission of uh, you know nodes, transmission of frames, and finally media access control. These are all some of the issues. So different classes of links, wireless links, wired links. So, and shift keys, amplitude shift key. So where amplitude is shifted. So for 1, 0, there is no amplitude. Frequency shift, there is a frequency, normal frequency for 1. For 0, there are varied frequency. Phase is negative phase is for 1, positive phase for 0. So phase shift key, this can be used. Link capacity, Shannon formula, based on this I can ask one question. And encoding schemes, what is this NRZ will do, NRZI will do, Manchester will do, what is framing? So bit oriented, byte oriented framing, frame formats, please take care of frame formats. There are 4 different frame formats, all 4 are important. So in the examination, they will ask all frame formats. The last one is Sonnet clock based framing. Error detection, you have parity check, you have checksum, you have cyclic redundancy check. In parity bit, you have even parity and odd parity. So based on number of ones, you will decide. Checksum is nothing but finding the total. So if this is the data, if you add this, so you will get total, and total will be complemented and it will be transmitted. So that is checksum. And cyclic redundancy check. So you have a message, you have polynomial. So generated polynomial, you certainly represent, you divide it, and finally whatever the reminder you get, for this reminder you will going to add so 1 less number of the polynomial generator, and number of digits you add, and you call it as CRC, and you transmit. Reliable transmission, you have simplex stop and wait transmission, sliding window protocol. So, and we have go back n. So go back n will discard all the packets whenever there is an error. So in selective repeat ARQ, only erroneous will be discarded. All others are taken. So negative acknowledgement is sent only for that. So that means it will be packet number 2 will be retransmitted again. Okay. Next, we have different types of network. Ethernet. So what are its physical properties? How Ethernet works? What is the frame format of Ethernet? All those things. And Ethernet, how they addresses physical address, how it is done. So transmission algorithms, P persistent. What is collision? How to avoid collision? All those things. Token ring. So how exactly token ring works? Wireless networks. what is the wireless network, how exactly it transmits, and wireless networks frame format, and so how collision avoidance is checked. So here, what are the two problems? Hidden node problem and exposed node problem. And you'll also talk about distributed system. So how exactly packets move from or nodes move from one region to another region, how exactly it moves, how exactly it is uh, taken care, what is frame, probe response frame, associated request frame, so associated response frame, how exactly it works, and frame format we have discussed. Lastly, Bluetooth and Bluetooth applications. So this is what the second module is all about. The quiz questions I have already shared in the Google class. So some of the practice questions where you have to certainly carry out, and based on the same way and based on your notes, I have prepared the quiz. It is mandatory that everybody should take the quiz. Okay, so it is mandatory that everybody should take the quiz, and certainly. Meanwhile, we have already started working, going to the college and working from the college. So if anybody wants personally anything to be clarified, you can come to college. We are available all the days. Okay. So from yesterday, I have started going. So that's all for today's class. We'll see on Thursday. So that's all for today's class. The entire class recording will be available on this particular website, and also the study material notes are also given in this link. Thank you.